Welcome to This Explainer. Today we're tearing down the blueprint of something incredibly fascinating, an elite engineering role. We're diving deep into the exact specifications for a design manager of open-die hot forging presses over at ISGEC Heavy Engineering. We're going to find out exactly what it takes to design and build the absolute titans of modern industry. But hey, to really get the role, we first got to understand the machine itself, right? The open-die hot forging press. Now, we are talking about machines that literally shape our modern infrastructure. Imagine a massive block of solid metal heated up until it's glowing white hot, being struck and squeezed by thousands of tons of pressure just to form giant industrial components. These are definitely not delicate little gadgets. They are colossal beasts operating under the most extreme high temperatures and pressures you can imagine. And the person sitting in this role? Well, they're the ones actually tasked with designing them. So, here's our blueprint for today. First, forging massive industrial machines. Second, the master engineer's arsenal. Third, blueprinting and critical calculations. Fourth, cross-functional team collaboration. And finally, number 5, career growth and rewards. All right, part 1, forging massive industrial machines. Setting the stage at ISGEC. 10 plus years. That is the golden ticket here, folks. ISGEC absolutely isn't looking for someone who just graduated and wants to tinker around. They require over a decade of highly relevant experience. We're talking 10 solid years totally immersed in heavy machinery, hydraulic presses, steel plant equipment, or forging equipment design. And why is that? Because the sheer scale of an open-die hot forging press means there is literally zero room for beginner mistakes. You're designing machines where a single failure could be catastrophic. So, that decade of experience, it's essentially a proven ground. It's a testament to some deeply battle-tested expertise. Now, all that experience has to be built on a rock-solid foundation, specifically a Bachelor of Engineering or Bachelor of Technology in Mechanical Engineering. But a master engineer needs way more than just the degree. They need a profound understanding of machine design and manufacturing processes. Just take strength of materials, for example. When you're dealing with extreme heat and thousands of tons of force, knowing exactly how a material is going to behave, bend, or break under pressure is, no joke, the difference between a successful run and a complete disaster. Moving on to Section 2, the Master Engineer's Arsenal. Let's look at the technical skills and tools. So the required skill set is kind of split into two distinct arenas. First up is core modeling, which relies heavily on some serious SolidWorks expertise. You're doing 3D part modeling, sheet metal work, and critically, large assembly management. A single forging press can have thousands of massive interlocking parts, and you have to manage all of that in a digital space like a giant 3D puzzle. But just drawing a cool 3D picture isn't nearly enough. That brings us to the second arena, validation and detailing. You have to turn out the exact manufacturing drawings and do rigorous design validation using geometric dimensioning and tolerancing. Plus, before a single piece of steel gets cut, the engineer uses FEA, finite element analysis, and simulation to digitally prove the design is actually going to hold up under intense physical stress. Okay, on to Section 3, blueprinting and critical calculations. This is the real heavy lifting. See, the design manager is ultimately on the hook for the numbers that keep this machine from literally ripping itself apart. The daily grind involves rigorous math, load, and stress calculations that dictate exactly how much punishment the press can take. Hydraulic force calculations are super critical because, well, hydraulics are the muscles of these presses, driving those massive dies together. Then you've got shaft design, exact component sizing, and frame strength calculations. Think about it. If those frame calcs are even slightly off, the entire machine could warp under its own operating pressure. These numbers absolutely dictate the machine's survival. Honestly, engineering at this level is the ultimate high-stakes tightrope walk. Every single component you select has to perfectly balance strength and reliability with cost, safety, and service life. I mean, you could design the strongest press in the world, but if it blows past the budget by 10 times and eats up way too much energy, that's a failure. On the flip side, if you cut cost and compromise on safety, absolute disaster. This balancing act is basically the golden rule the design manager lives by every single day. And what exactly are they balancing all this on? Massive, critical components. We are talking about bearings that have to support literal tons of rotating mass, huge hydraulic cylinders, pumps, and valves controlling immense flows of pressurized fluid, heavy-duty gearboxes and motors, right down to the specific fasteners and structural members holding the whole shebang together. The design manager is like a master conductor here, ensuring every single one of these heavy pieces plays perfectly in harmony to meet those strict safety parameters. Which brings us to Section 4, cross-functional team collaboration, taking it beyond the CAD station. This leader really has to navigate two totally different worlds. On one hand, you've got isolated, super focused engineering work. You're alone with your math, deep in SolidWorks, sizing up components. It requires deep, uninterrupted focus. But then, boom, you pivot to collaborative execution. A design manager has to take those digital blueprints and coordinate intensely with manufacturing and production to actually build the thing in real life. They work with quality control to enforce standards, procurement to buy those massive components, sales to align with what the customer actually wants, and the service teams for post-installation. So you have to be a brilliant solitary thinker and a highly effective team leader all at the exact same time. All right, let's talk about where this takes you in Section 5, career growth and rewards, the upward trajectory. This is absolutely not a dead-end job. It's a launch pad. Starting as a design manager and successfully leading these massive press projects paves a very direct path upward. Step 2 leads you to roles like senior design manager, engineering manager, or head of design. And ultimately, Step 3 is reaching the absolute pinnacle of the technical ladder, becoming a chief design engineer or technical manager. The momentum you can build in a heavy engineering career like this is incredibly strong for folks who can deliver. And yes, there are concrete financial rewards, for sure. The estimated typical range sits between 15 to 30 lakhs per annum. But there's a pretty cool caveat here. Candidates with truly specialized experience, specifically in forging press design, can actually command an even higher package, depending on their exact expertise and negotiation skills. It just goes to show that in the world of heavy industry, highly specialized, proven engineering talent is incredibly valuable. So where does all this magic actually happen? Well, the physical home for this role is anchored right at ISGEC's massive engineering and manufacturing facility located in Yamunanagar, Haryana. This is the base of operations. It's ground zero, where those digital SolidWorks models actually get turned into thousands of tons of physical working steel. Now, if you're sitting there thinking you have the decade of experience, the SolidWorks mastery, and the mathematical chops to actually take this on, here's how you apply. You can email your application to monica.gupta@isgec.com. You're going to need to include your updated resume. A cover letter is highly recommended to explain your specific background, and crucially, include a portfolio or a list of your relevant heavy machinery and press design projects. Honestly, that portfolio is exactly what will make you stand out to the hiring team. We've completely unpacked the exact anatomy of an elite heavy machinery design role today. We've seen the sheer scale of the math, the software, and the cross-functional leadership it takes to build machines that literally shape our world. So I want to leave you with this final provocative thought. Do you have the vision and the technical grit to forge the future of heavy engineering? Thank you so much for hanging out with me for this explainer. If you found this deep dive into the blueprint of a master engineer as fascinating as I did, definitely hit that like button, share it, and subscribe for regular engineering updates. And hey, don't forget to check the links to connect with the source on Facebook, Instagram, LinkedIn, and WhatsApp for collaborations and suggestions. Keep learning, keep building, and I will catch you in the next explainer.